Hi, John Valvano here, and I'd like to show you some of the steps if you're going to attempt the extra credit. That's option 1 of the extra credit. Now, what it does is you are going to record or create a song, and you're going to encode the song as notes of music. All right, so I'm going to start with some sheet music, talk about the data structure, and show you how to paste in material from the DAC. Excel sheet. We'll have a problem associated with REST, and we'll draw some flowcharts and embed some code into Lab6. Okay, let's get started. Again, the idea here is to play a sequence of notes, and a sequence of notes is music. Okay, and a couple of the parameters that matter associated with music are two. First is the frequency. Okay, that's the pitch that we had in our regular part. And the second is the duration, right? The length of each note. Okay, and so if we think of sheet music as a sequence of durations and pitches, and we play them one after another, we're going to hear the music. One of the parameters that's important for music is called tempo, and that is how fast it runs. Now, with regular metered songs like this, a quarter note is 1 beat. And if we're running at 120 beats per minute, that's essentially each quarter note is then going to be a half a second. Now, it turns out I downloaded some sheet music from the internet that uses cut time, which runs twice as fast as regular time. And so we're going to see in this example I'm going to do that a quarter note is 1/4 of a second. Okay, and we'll see that in terms of my tempo. All right, let's look at the sheet music. Okay, so I downloaded Deep in the Heart of Texas, and this is sheet music. Again, this is cut time. It's got 2 sharps, F sharp and C sharp. And if we look at the music, we can see that it has a sequence of notes. And there's an A note right there, okay? And it's got a duration of a quarter. It's a quarter note, okay? And the next is a D note, okay? And it has a duration of a half. Okay, so again, the quarter note's going to be 250 milliseconds, and the half note will then be 500 milliseconds. Okay, and then I'm going to sequentially write down my music as a sequence of notes. Okay, so that's an F. Of course, it's F sharp. And it's a half note. Okay, so a couple of the problems we can bring up right here, and that is the rests. We're going to need something that represents a rest. And so I'm going to develop a pitch, if you like, called quiet. And I'm just going to call it Q for quiet. And it's going to have a pitch. In this particular case, it's going to be a quarter note. Okay? The second problem is going to exist right here, and that is if we look at these 2 half notes, they're the same pitch. And when I display them on my DAC, right, if this is the first half note there, okay, and then I display the second one right after it, okay, here, you're going to see that this is going to look like one continuous wave, and it will sound like one. And so we're going to have to inject in between 2 notes of the same pitch. We're going to have to interject some sort of quiet in here so that we can hear. Okay, so we're going to inject some sort of quiet right here so we can hear the 2 notes separately. All right. If you want to learn about sheet music, you're going to take some other class. But we're going to talk about embedded systems. Okay, so I'm going to embed or encapsulate this sequence of notes in my data structure. Okay, I'm going to use a second timer, and it turns out that timer is going to be 32 bits. And if I have a 32-bit timer running at 80 megahertz, the longest note that I will be able to generate is going to be 53 seconds. And that's plenty long enough for this class. Okay. Again, my quarter note was 250 milliseconds. Okay. So I'm going to create a sequence of defines to represent the duration of each note. So I'll start off with the bus frequency, which is 80 megahertz. And if I want to have a quarter note, which is 250 milliseconds, what I'm going to do is take that 80 million divided by 4. That's going to be my timer reload value to generate a quarter of a second. And then based off a quarter note, I'll have a half note, which is twice as long. And if I had any whole notes, they would be 4 times as long as my quarter note. And like I said, if I have two notes of the same pitch, I'm going to have to put a gap in between the two notes so that they're separated. And so you'll see I need a little short time for that gap, and I'll just call it G for gap. Okay. The next thing is I need, so that's the duration, and the second aspect of the music was the pitch, and we saw these define statements in a previous video that were captured out of this Excel sheet. We're going to have to make a couple of changes to it. First of all, we need an F sharp. Well, it turns out F sharp's the same as G flat, so F sharp and G flat are the same note, but we'll create an F sharp command define for F sharp. And the second is we need something that is quiet. Okay, and so again, I'll define an F sharp, and I will define a pitch called Q, which is the largest reload value. It turns out it'll try to generate a 5 hertz waveform. We won't be able to hear it. Okay. All right. So remember, there were two aspects. Of the music, and the music was a sequence of notes. Okay, and my first note was an A0. Okay, right there. Okay, A0 is going to be a pitch 440, and it has a length. Okay, it had a length of a quarter note. Okay. Now, if I wanted to start at the beginning of the waveform, I could have put in a quiet in front of it. Okay, and again, each frame, each bar was 3. Each bar was 3 quarter notes, so I could have 3 times Q right here. Okay, and so this is going to be my data structure here. Okay, where each note, these are my notes, and each note is a pitch and a duration. Okay, again, what I'm doing here is copying the sheet music into something I'm going to be able to deploy in my software. All right, the next note was a D. Okay. All right, there's my D pitch. Again, these are reload values that I'm going to plug into my sound play in order to make this work. And it was a half note. And then I had another D note, which is a half note. And then I had an F sharp. All right, an F sharp, which was a half note. Then I have a rest, which was a quarter note, and then it started over and ran it again, and ... Okay, quarter note. Okay. Now, remember, one of our problems is these two Ds are going to sound like a whole note. So what I'm going to do is I'm going to stick right in here. I'm going to sneak it in right there, a quiet spot. Q, remember, stands for quiet, and I'm going to give it a gap length. But in order to make everything work out beautiful, I'm going to have to subtract off a gap length there. Okay, so this is going to be my data structure here, which is the first part of Deep in the Heart of Texas. All right. All right, so what kind of data structure allows you to create an array where each element has different things? So obviously I'm going to have some sort of struct. Okay, I could call it whatever you want. Struct note. And then I'll have my fields. The duration field is going to be these reload values here. And so we'll call it duration. And then, I'm sorry, duration is this one. The one before it is going to be the pitch. Okay. Okay, so these were the pitches that are going to be into that field, and these are the durations which are going to be into that field. Okay. So I'll create and then do the usual stuff like we did in Lab 5, create a type def of this thing, struct note. Now, am I going to put it in RAM or ROM? Well, I'm going to put it in ROM, so I'll make it a const. Const struct note, give it a cool name, note type. Okay, so that way I can create an array of notes, which will be my song. Okay. All right. So now let's think about how we're going to put it together. So we talked a little bit about the structure. And now, as you know, we have the cystic interrupt, which is, depending upon some sort of semaphore, is going to do one output to the DAC. This was our basically our regular part solution. But what I'm going to do now is create a second interrupt service routine, a second timer, ISR. And this ISR is going to be invoked whenever it's time to change a note. And we saw that array in the other table, so really what I'm going to do is, I might have some sort of decision about whether or not I'm playing a song. And then what I'm going to do is have some sort of index into my song table, okay? And what I'm going to do is capture something out of there. I'm going to do a sound play of the pitch. And so I'm going to have my song, bracket I, where song was an array of note types, dot pitch. And then what I need to do is to set the duration for that song, and we'll see that there is a register in my timer called tail R. Okay, and I'll show it to you in software in a moment. Tail R, and I'm going to set it equal to song bracket I dot duration. Again, the units of duration is going to be 12.5 nanoseconds. That is going to be the length of that. And I'll do some sort of thing, I equals I plus 1, and if the song is over, and then we're going to somehow quit. This is some sort of S flag maybe. If it's equal to 1, and down here I'm going to set it equal to 0. And that'll stop my... All right, so we're at the end. And there's lots of ways you could make this thing work. You can arm and disarm the interrupts, whatever. Okay, so that's a little bit of the flow chart. Let me go over and capture a few things first out of the Excel sheet, and then make a module for music. All right, we saw this DAC Excel sheet before. I'm going to open it up. And I'm going to make a couple of changes here because my waveform is bigger. I'm going to use a 6-bit DAC, so I would have created a 64-point wave form, and so that will recalculate the periods for my notes. So I'm going to capture this, copy. Then I'm going to go over to my Lab6 a program in sound.h. Okay, I'm going to replace this table, which was for 32 size, with the one I just made for 64. Okay, paste. Now what I want to do is create another module. Okay, so we can either write the H and C files and then import them, or we can just add a new item to source. Okay, and so we'll add a C file. We'll call it music. Okay, which will contain the thing that plays music. And now, since I'm going to use a timer, what I'm going to do is I'm going to open a file in periodic timer, this one. Okay, open, I want that one there, timer A. And so I'm going to take this stuff here, select all, copy, put it in my music file, paste. Okay, so what we got here is a starter program for a second periodic timer. Okay, and basically, if you were to call this function, it will generate a periodic timer. Now, I'm not going to need to do any function call, so I'll remove that one. Okay, and get rid of this. Put in. I need to do a wait here. Volatile. Int delay, and right here I'm going to go delay equals 0. That'll let the clock stabilize. All right, so this is going to let the clock stabilize. Okay, so this function here is a lot like Sysdig, but a little more complicated. Let's see what it's in here that's interesting. There's the tail R register I was talking about. That's the thing we're going to change when we want to set the pitch. We can enable it with this line. And here's my interrupt service routine that's going to do the tasks and walk me through. Okay, so this is the thing that's going to run every time I change the note. And so, again, I will check a flag to see if I'm playing a song, and then I'm going to do, if I'm going to play a new note, I will then call sound play with that note. And I'm going to reset this value here to be the duration of that song, okay? The duration of that note. And that was my structure, however you want to set it up. Okay, again, increment I, and check for end of song. Depending upon how you end, you may want to make the last note a quiet note or whatever. Okay, so that's basically the steps, and that is to import. And so we're going to have to create a user callable function, music play, and it's going to take something like we saw that we created a note type. And create the song that we want to send, right? We'll send it in an array. And duration of the song, however, we're going to create a function which plays a song, okay? And you can set whatever parameters you want for how that song is played. All right, enjoy. The extra credit part's kind of fun. And so in summary, what we've done is we created a second interrupt service routine. This one runs a lot slower. This is going to get invoked every time I want to change the note. This line of code will clear the interrupt. All right, so enjoy.